Okay, everybody, we are set to get rolling here on our next presentation. So I'm actually really thrilled we have Ben Wilson here with us. And Ben is a senior environment artist, and he is working at MachineGames. And Ben is going to take us through a presentation on Wolfenstein 2. Thanks a lot, Ben.
Thanks. Hello, can you hear me? So hi, everyone, and obviously welcome to the talk. So today I'm going to be going through some of the ways that Substance was used to help texture the debris assets for Wolfenstein 2. I have to first say that I'm a little bit under the weather, so please excuse my voice. But thank you for joining us, and I'd like to extend my thanks to ZeniMax, MachineGames, and obviously Allegorithmic for hosting us. So I hope you like it. As Wes said, my name's Ben Wilson. I'm a senior environment artist at MachineGames. I joined the team a little over a year ago, and there I've primarily been focused on texturing and helping to set up our Substance pipeline. So I'd actually like to get a show of hands if anyone's played Wolfenstein 2. Awesome. Well, for those who have not, it's an FPS, like action-adventure game. It's set in an alternate universe where the Nazis won World War II. So I first got a launch trailer, but just a slight disclaimer, it's quite violent, so I hope you're all mature adults. Oh, doesn't seem to be working. I've got a backup here.
Welcome back to America's #1 game show.
My brothers and sisters of the United States of America, tonight, we, the free people of the resistance, ask you to become one of us. Did you forget? They beat us! They murdered us! They executed us! They fucked with the wrong country!
Come and fucking get me, you fascist Nazi pigs!
You keep saying where you shouldn't be playing.
And if tonight we see you on the streets with a knife, or just your clenched fist fighting the powers that be, then you are one of us!
These boots are made for walking.
Tonight,
And that's just what they'll do.
they burn.
One of these days, these boots are gonna walk all over you.
Cool. All right, so to give a little overview of the talk, we're first going to start by briefly showing how we're set up sort of internally at MachineGames, and just talking a little bit about the theory behind that. Then we'll look at some tileable textures. Then we'll move on to, in particular, the wall modules and the assets and how they were made. Then we'll talk about some of the debris piles. And then finally, we'll build a custom node and show how that kind of ties in with the internal structure that we have. So for Painter, we kind of embraced the shelf concept to meet the various needs of the project. So we actually had one shelf which was all the stock allegorithmic content, but we had stripped out and removed some of the stuff that wasn't really relevant to us. This was stuff like stylized materials, shaders, color lookup tables, that sort of thing. And this was just done in an effort to help speed up load time. Then we had a MachineGames specific shelf, and this is really intended to be shared amongst the whole studio. It's where we publish our base materials, any custom nodes, that sort of thing. Then we also actually had a Megascan specific one. Not all the artists use it, and the library is quite heavy, so it made sense to be separate. And then we actually had, previously, there was an issue with, like, the shelf was really overpopulated on the previous projects, and there was a lot of files just sitting on, like, local machines. So We wanted to keep the essence of iterations, but we still wanted things in Perforce. So we set up kind of small teams or map-specific shelves. That really let everyone quickly share and iterate, but it keeps everything in Perforce. And then we would periodically go back through and kind of update and bring forward any of the stuff that's relevant and can be distributed then to the whole studio into the main machine game shelf. For Designer, we really then kind of mimicked the way that Painter was set up. We had the machine game shelf, and this is where the source SBS files live, all the base materials and custom tools. Again, Omega Scans 1, and also the map team shelves. For Designer, the shelves are really easily maintained via the config files. So you just add the config that you want, which then adds all of our custom scripts, the Perforce integration, auto checkouts, it handles all the naming conventions, that sort of thing. And it lets our artists actually choose which kind of content they want and which shelf they want to add. It also adds a nice little library into the UI, which houses all of our custom tools. Sorry. So the nice thing about this is the custom nodes are added via categories and URL paths in the attributes for Designer. And it really lets us group assets, control what's visible, but everything is still searchable via like the spacebar. We're just going to gloss over the planning because it's not really the point of the talk. But before we started building anything, there were some considerations which we needed to address, and I think these are worth talking about because it really informed the way that the art was built. So firstly, it was a 60 FPS game, so the poly counts are very tight. There's a lot of shader limits. There's really no fancy tricks. We've only got the one UV channel. So texel density really informed a lot of the decisions that going forward. Like most projects, the deadlines are very tight, and you want to be able to iterate quickly and be as non-destructive as possible. So we're going to look to maximize reuse wherever we can. And then we want everything we want all the details to work together and have everything match. So if you have some debris on the ground, you want it to be the same material that's on the walls. And then, of course, we want to match the art direction. I like to think of Wolfenstein as quite crunchy textures with some strong, bold shapes. So before we started any of the art, I actually worked on the map primarily with Ivan Martinez. And our first step was we collected all the reference and the concept art, and we identified which assets we needed to build. And then we even actually mocked up all the textures that we would need for the map on paper first. The nice thing about this is it really makes you consider the whole scene. You're never really working in isolation. You're seeing the bigger picture and how everything sort of fits together. And it makes it much easier to establish a texel ratio between assets. And it also informs the size of the modules that you're going to need. Typically, when talking about the size of the modules, it's better to work with clean numbers. So if you have a brick that's 10.2 centimeters, it's better to round down to a nice 10 centimeter whole number, just because it makes everything much easier to snap to the grid and everything working together. Obviously, a lot of things change with the planning, but at least it gave us a good starting point. So when we started building the assets, there's obviously a million different ways you can go about this, but this is how we kind of conceptually built or thought about the assets. We split them conceptually into two groups. The first group was sort of components, and these are things that are really just there to help you make the in-game asset. They're not actually intended to go in-game, But there's stuff like sculpts, any base materials you build, specific for the assets, or any designer tools, that kind of stuff. And knowing that we were going to use a lot of debris, working with high poly meshes is just not really viable if you're doing simulations and that kind of stuff. So we actually built a whole bunch of medium resolution assets for all of the sculpts that we built. They went through a very traditional process of we sculpted them in ZBrush and made your low poly mesh and baked them out with material IDs and textures. So the whole point of this is just to give us a library of reusable pieces. And as mentioned, they're not actually used in-game, just to help us build stuff. Then we would have the asset packs. They are the collection of files related to in-game assets. They include stuff like the setup of in-game assets, any Modo files or smart materials, presets. They obviously include the in-game assets themselves, modular kit files. If you have any textures that are intended to be blended together, this is like an asset pack. For example, if you have like a modular pipes kit, the asset pack would be the file with all the pipes, but also any files used for baking and the painter files, that sort of stuff. What's important here is that these two concepts aren't tied together. You could have many components being used to build your assets. So this is all awfully abstract, so we'll actually look at how these two textures were built to provide some context. So they went through this general process. We started with the sculpt. We then made some medium resolution versions of these, baked out all the textures. Then they actually went through a simulation in Modo, and this was just to help clipping and try and give some more believable results. Then it went into Designer, where we kind of tidied up and added a few extra bells and whistles. So here, this would be what the component pack is, and this is the asset pack. So here are the actual sort of components that we used that we're going to have a look at. And these first started out in Modo, and as I mentioned before, they wanted to be on clean numbers. So I scaled them so the bounded boxes are all nice whole numbers and very easy to work with. They then went into ZBrush to get sculpted. They're very quick. You don't really need a lot of detail since design is going to do so much of the work for you. But since we knew they were going to be simulated with, these high polys are just too heavy. So we then built these medium resolution versions, and these are the ones that we would actually simulate with instead. They were just decimated from ZBrush, and you can see, despite being relatively low poly, it's totally fine, because in the end, these will get baked down to a 2K texture or less, so most of the detail will get lost. And indeed, Designer will then fill that gap. But what we did do, which was super important, was add material IDs to these meshes so that it became very easy to add materials in Designer later. And then these were textures as usual. They were just auto-unwrapped from Modo and then baked from the high poly and textured inside Painter. We can actually have a look at the Painter file for that. So these were the assets, and I just want to highlight here that there really wasn't much time or effort spent on texturing these. I have a base layer here for the specular, which is just some values that the engine expects. But from here, I just start pulling in smart materials or base materials that are already part of a Substance Painter. And then I'm just using the material ID to apply the mask. But I really did nothing. Indeed, this brick surface actually I built in Designer specifically for this asset. And this gets reused quite a lot going forward. But the rest is very simple. It's dirt overlay with a sharpen, and then there's some edge highlighting here with a custom node, which I built also inside Designer. Okay, so videos aren't working too well. So here I have a preview of the kind of the process I went through with simulating the debris pile. The first thing that I'm really doing here is I'm just kind of duplicating all the meshes down just to sort out my ratios, and it's just how Modo expects your when you splatter them down. But the idea here is that I start with the larger shapes first and then work my way down to the smaller shapes. I do this by just scaling them down and lifting them up and doing a simulation. The idea here is I want to do the simulation in these kind of layers just because if you simulate hundreds of these assets in one go, it becomes very heavy. So doing them in layers just makes the load a little bit easier. But what you just saw there was to make the asset tile, I just delete one side and then duplicate over the other, which makes the meshes tile. And then there were some gaps here which I didn't really like, so I deleted them, and now I'm making it tile again. I'm having some problem making selections here. But here I'm looking for stuff which I know won't bake particularly well. So I'm looking for any of the meshes which kind of fell really protruding too far up on the texture. I'm kind of looking for something generally quite flat. And then once I'm happy with that, I then do another layer of the smaller stones. And we'll skip ahead a bit because the process is very similar. But I go through and do a few of these layers, and then when I'm done, I just apply all the textures that were baked out of Painter, and then I rebake them down from Modo and bring them into Designer. Okay, so this is what we ended up with outside of Modo when we baked out and brought into Designer. So this is the height map, the straight bake from the height map. Inside Designer, we first started by adding a bit of like edge and surface detail, and then a simple ground just so it's not flat. And then we start filling the gaps by adding a few more stones with another layer. Here's another layer. I'm not sure how well this is coming through, but we added some splinters as well. Finally, a bit of dust. So this is what we started with, and this is what came out from, and this is the work that Designer did. And then this process was very much the same for the diffuse. This is what was baked out of Modo. We add the grounds, and then we start adding in color information for all the stones. Here's the wood splinters. The values were a little bit dark, so I lifted them up. I wanted the bricks to pop a little bit more, so I added some hue. This is the material inside the brick, some dirt and dust. Called out the edges a little bit. Some paint on the woods, and kind of like speckled dust. So this is what the final diffuse looked like. And we can jump into Designer and have a look at this file as well. So here you can see these are the input maps from Modo. So we have our height with an auto levels just to fix the height range. And then we have our ID map generating a whole bunch of masks, which we'll use later. Here's our diffuse, and here's our gloss information. So this chunk here is where I first defined the surface detail. And it's just a bunch of black and white spots, added on top, a slope blur. It's being masked by the AO, and then I add a little bit of dirt on a very low value on top. I'm sure this is all very familiar to everyone, but here is where we add the stones. What's quite important here is I have this little node here, which we call Atlas nodes. And we'll have a look at what these are and how they are built a little bit later. But they're being plugged into the tile sampler, and we're using the mask to determine where they should spawn. This is then blended together with another custom node to control the height blends. And what's different about this one is it just uniformly adds the height detail on top. And this is the node that we'll look at building at the end of the presentation. Then the next layer just uses the AO to derive where the stone should populate so that they only appear in the crevices. And this gets done for a few more layers. You can see we've added all our stones now in the gaps. And then we add the wood splinters. It's the same process. We have another one of these Atlas nodes for the wood splinters. These meshes were actually built in Houdini, but you'll see that they're just extracted out into images into this Atlas node. And then we add, finally, just a little bit of the dust on top, and that was really it. We generate our normal and our AO map. The diffuse is also a similar process. So we start by taking our our output from Modo. I then run a gradient map to give us our kind of base color for the ground. And then I start layering in all the different stones as before. Here I'm actually using a concrete material, which I believe comes stock with Designer. So here I'm being super lazy again. But I quite like color pickers, so I prefer to use the color match node where I can instead of the HSL node, just because I like being able to visually click with this thing. But it's using all the same. It just blends between the mask from the blend, so only masks the new stones which are added. So this happens a few more times for each of the stone layers. And then the wood splinters. This wood texture just came from, it was somewhere in our library. I'm not exactly sure who the author is, but it was in the MachineGames library, so I just stole that. And then I use another color match node here, which is what I use to pop out the brick colors a little bit. And then the inner material is some dirt and dust. And then we call out the edges. And here's where we add the wood paint, and then a slight sharpen just to tidy up the values a little bit. And here's that speckled dust on top. And for the gloss, it was very much the same. Here's our concrete, and we're just blending in using the same masks. And I'm just using the same concrete for each of them with different values. All right. Okay, so from this point, making variations becomes quite easy. We can just expose some of if we expose the input slots and then some of the settings on that original graph that you saw, we can then just do another simulation in Modo and then plug the outputs from that into the original graph, and you have an entirely new variation. And because we've been setting up the ID maps and baking those out from Modo, it's also quite easy to make variations of different materials. So here I have the input maps coming in from Modo, but instead of using the concrete, we're now using a plaster, but otherwise the graph is the same as what you saw. And here's two examples of the plaster that we made. So in these particular two, it's again a new simulation in Modo, but with pretty much the same graph with exposed inputs. So just to give a quick recap, we started by building a bunch of component meshes with all of those small sort of concrete and brick assets. Then we used them to build a bunch of debris textures. it can be quite cumbersome going backwards and forwards between Modo to do these simulations, but to give you an idea, that time-lapse I showed you was only 30 minutes work. But remember, the whole point of that was just to really reduce clipping. So not all the textures are going to need it, and really you can spend most of your time inside Designer for a lot of textures. But one of our main goals was to keep things consistent. So we can look at another way now of reusing these component meshes in the form of these Atlas nodes. So these Atlas nodes, the idea is to basically generate an Atlas texture set, crop out the images, and then just convert that into a nice, convenient node. For the bricks, I just laid them out in Modo and then baked them down. And then these are the textures I baked out. What's important, though, really is just these textures. It doesn't really matter how you generate them. They worked really well with scan data, for example, which have full sets of textures. But in this particular example, I just baked out an ID map, a height map, and an alpha. I actually found that doing the crops live in the graph was quite performance heavy. So instead, I run them through another substance graph first, which generates a whole bunch of cropped images. And then I package those cropped images into another graph to just give me a selection slider, which just makes everything a nice package on the user end. With a little bit of scripting, I haven't done this yet, but this would be a perfect time for the automation toolkit to just plow through this entire process. But we can take a look at, sorry, one sec. We can take a look at the graphs for this. So this is where we take the images in and do some crops. So here you can see I've got my ID map baked out, my alpha, and the height map. And here is where we actually do the cropping. We can have a look at, we're not going to go through the math because frankly I don't know if it's the efficient way of doing it or not, but it basically just crops the image down, and it's tied to these these parameters. So you set a grid size, and then you can select which grid that you want. We then dilate the pixel values, and then we downscale the image to something a little bit more reasonable. And this just is a repeat for all the channels. Then, let me give this a second to load. So this looks way scarier than it is, but this is basically just that grid graph with a different select value for each. And those are then set to outputs. And the reason why there's so many is just in case I needed them. But I think in the case for this actual node, I ended up using 6 or something like that. I'm not sure. So once everything's saved to the outputs, I then just plug them all into a multi-switch, which then just packages them up, so I can then just expose the input selection, and then we can have a new node here. If I just make a new graph and drag this in, we can now see that we have all of our bricks on a nice slider here, and it also has matching height data as well as the ID map. So with this Atlas node, I used it to make all the wall textures. And then being inside Designer, it's also very easy to make variations. In practice, I actually found that I didn't quite have enough variation with the sculpted bricks alone. So I combined them with a more traditional kind of Designer-based setup and blended between the two. I know this image is super small, but all you really need to see is that here is where the Atlas node is being used. Here is a more kind of standard brick setup, and then I just blend between the two. So while we're talking about bricks, we can take a look at the wall modules. They were built with a system which I'm sure is familiar to most of you here, but it's basically some kind of wall mesh with a cap that sits on top like this. In the case of Manhattan, we actually built 3 angles of these cap meshes using the medium res assets, and then we baked them down. The idea here was just to combine them together and build up more complex shapes, but it's essentially a compromise between modularity, time, and unique detail. But since we know the target texel density, we know how many bricks tall each one of these meshes should be, so it makes making the caps very easy and making it match with the tileable texture underneath also very easy. So we can take a look at how these wall meshes actually looked inside Modo and apply to the game. So here's some of the wall meshes in Modo, and you can see that this is where the cap mesh sits. So let's do another quick recap. So we made 1 component pack so far of the sculpted bricks, concrete, and wood. We made a bunch of, we then made medium resolution versions from that. With that, we made some tileable material sets and their variations. And variations were really quick because we just exposed some inputs and the parameters and then just plugged in new outputs from Modo. We then even made plaster variations by repurposing the ID maps. We made wall tileable textures by repurposing the components into Atlas nodes. And then we even found a solution for our damaged brick edge by using this cap mesh. And here, everything still matches because we've been reusing those same components right from the start. What's great here is that every time you build something, it can potentially be added and expanded into the library to expand the tools. So let's have a look at these debris piles in particular. These are kind of smaller debris piles. They can be thought of as sort of filler meshes. They're intended to be very small and like highly reusable. They're there to sort of plug holes and like pile up against things and fill dead space, add detail, that sort of stuff. They're directly in the playable space a lot of the time, so they really need to match texel ratio and to fit onto one texture, which really limits the size that they can be. I think these particular ones were roughly 2 meters. But the process for this wasn't really very different from the tileable textures. They were simulated in Modo, but in this case, they're using more than 1 component pack in the case of the larger columns and the car seats and stuff. But they were simulated in Modo, and then a low poly was built and unwrapped, and then those textures were then exported and brought into Painter and finished off from there. It can be quite time-consuming building all of these components, so it's really important to reuse other people's work wherever you can. So before starting these, like I walked around the studio just pestering everyone for high poly meshes for just junk and debris that I could use. So let's have a look at the Painter file for this as well. Should have started loading this one earlier, I think. Here we go. So these are the bakes that came straight out of Modo. And then I'll run through the layers here of what was added. But it was very similar to the components which you saw before, where I'm being super lazy and just throwing on base materials. This was actually the material that you looked at earlier, which forms the base of like the underneath surface. And then I just start layering in some different types of concretes, again using the ID maps. with a color selection here. It's just picking from the ID map. And the only tweaks I'm doing is some color tweaks. Other than that, I'm not really doing much painting. Here's our brick again, and this was using the same base material which I built for the components. The rough brick, some leather, plastic, concrete, some fabrics, some color tinting. Here's specular for the engine, and we had some metal in, some dust, and some dirt to kind of tie it together. So you can see that it's really the kind of the normal map and the area that's really doing the work here. Most of it's very simple base materials. Okay, so again, I do a new simulation and we have an entirely new asset. And because I've been using the same components, they have the same material IDs and the same colors, so they can reuse the same painter file. So once you have the one painter file, this automatically gets textured. You can notice here that there's actually a hidden traffic light. This is actually the in-game poly, low poly mesh. Because I didn't have access to the high poly mesh for this. So we can look at an example of how this sort of comes together. I think this debris pile is roughly 8 meters or so across. But it first started off by defining some volume for the pile. I then add some debris piles and, add some new debris pieces. And like this is another component kit, right? Here's another component kit. Here's our filler meshes that I just showed. And from here, it's basically a balancing act between performance and detail. And I think these debris piles went through an optimization pass to remove all the back faces that you end up with. So now we can look at building some of these, the height blend custom node. So here I've got like a quick preview to show you kind of like what the node does. I actually found this node from Bruno of Substance Share, and it just takes a cross section of your height data. So it's quite nice to visualize what's going on. But here, let's say we have a flat gray to represent our ground, and we've got some stones here which range from, as you can see, from 0 to 1, 7.5, and 2.5. And typically, when you blend them together with something like max lighten, like this is great, but the stone, which is 0.25, is now being lost underneath the ground. What this uniform additive blend node does is it just adds the stones on top of the ground layer and then gives us some nice controls for the intensity and the depth of the stones. And then also, if we have some noise in our ground, there's also a control here to determine how much of the surface underneath should be determined. So let's look at how this was built together. So let's add a flat color to represent our ground. I actually want to just grab these so we can visualize it. Don't know where my delete button is. I know how to use computers, honestly. Okay, so let's take our flat ground, something like 0.5. So we first want to add some stones, right? So let's just blend these together. But instead of blending them with lighten, we'll blend them with add. This is great, but now you can see that our stones are actually capped because these values are too strong, right? We're adding a whole 0 to 1 on top of 0.5, so halfway through this stone it gets capped. So we'll add a levels here to give us a control over the intensity of these stones. So now if we adjust this slider, you can see we have a nice control for our stones. So let's just expose this. We'll call it something like intensity. Oh, what's going on there? Yeah. So now we want to be able to control the depth of the stones. So we can then just subtract a value from this. So instead of doing it all in the function graph, we'll just use this flat color to represent our value instead. And since we don't need all of the pixels, we can then just set it down to something like 16 by 16, nice small number, and make sure this is set to parent so that it doesn't inherit the small number. And we'll just set this to subtract. So now we can see as we subtract a value, the stones are pushed underneath, which gives us a nice way to control the depth of the stones. So let's blend this together then. We'll use a height blend for this. Blend it with our ground. So let's expose now the subtract value and name that something like depth. So if we take a look at our cross-section here, oops. And then here we can see we've got our nice intensity control and then our depth for the stones as well. Ooh. Need to make sure that our contrast is set to 1. Yeah, you can see now the stones are going underneath. But there's a slight problem with this. If we say we reduce the depth of our stones, but then we want these stones to be a little less intense, we kind of got a problem here where the stones are sort of disappearing underneath. And if we have a look at this cross-section, you can see what's actually happening. So as we reduce our stones and then lower the intensity, the stones are being reduced from the lowest point. What we actually want to happen is them to be, the intensity to start being reduced from kind of the midpoint. You know, so we want our intensity, our depth value to be relative to our intensity value. So we can fix that as well by just multiplying our depth by our intensity. So we can get the float value for intensity and set that as the output. So now if we have a look at what's going on, as we reduce our depth value and then lower our intensity, the depth value is also getting smaller at the same time. So the end result is a nice clean depth adjustment, but also an intensity control in a way that you expect. So this is great on a flat ground. But if we have something more noisy for the ground, just throwing a Perlin noise here, make it not so strong. You can see that now our stone, because we're just adding the stone information on top of the ground, it's all over the place. So to fix that, we can add a blur and use that as the base information for our stones. So now you can see that the higher the blur value, the more smooth the stones are. If this value is really high, the stones are effectively the original data and not respecting the height information underneath. Whereas when it's smaller, the height data shows through. So we can expose this as well and call it, I actually called it, I think, feature size or something like that. But we also have another slight problem here where, as you can see with the cross-section, as the stones blur, we're also blurring the height map, and it's being blended through in places that we don't want. So what we actually want to do is then create a mask for the stones. So we can just take our stone information, create a mask for that, and use that as our mask for the height blend. And now you can see that the stones are only being, or the height data is only being used for the stones in the places it needs to. And then from here, we can make this as a nice clean node. We can create an output for the height. Let's call this something like height. And then another output. We can use the mask. This height blend node is great because it automatically gives you a mask for you. Let's call this one mask. And then let's change the height data to use an input grayscale instead. Let's give this a save. My awesome node. So let's make a new graph here and just see if this is working. Whoa, where is it? Ah. I really need to find where the delete button is. Okay. I should actually go through and name this properly. So let's delete these outputs because we don't need those. There's actually a really nice function in here just to clean the graph of the stuff we're not using. So for the attributes for the mesh, let's call this like height blend. We'll give it a category, call it GDC for now, and I'll show you what this means in a minute. And then give it a nice label. Cool. And can even give it a nice icon, because why not? So we want to make sure that it's being shown in the library. And then here you can see I've added this GDC thing, and as the file gets saved, this GDC filter, if we have a look, it's just reading the URL path for our shelf and also the category names. So as I set the categories here, they'll automatically be populated into this graph. So now I can just drag it in. We have a nice clean height blend mask, height blend node. So let's try this with a Perlin, just make sure it's working. Yeah, and there you go. Okay. All right, and then that's it. So if you have any questions, please come up to the microphone.
Hi.
Hi.
I wanted to ask about the blending of the edges of the debris piles. Like when they collide together, they should how do you tile the edges of the debris itself?
Sorry.
And
You're going to have to speak up. I'm sorry.
okay. Can you hear me now?
Yes.
Okay. So I wanted to ask about how do you blend the edges of the debris pile together, like especially in the engine? Do you use like alpha masks or something like that?
So you're talking about on the debris pile?
Yeah.
So how...
Yeah, I mean in the mesh itself, like when you do a mesh and bake it.
I'm sorry, there's a terrible echo on...
Okay, like when you use an actual mesh and bake it, like this mesh has like a very jagged edge
Oh, I
How
see.
do you blend this into the environment?
So you're talking about on these debris piles?
Yeah.
Yeah. So we use vertex blending to kind of blend the same kind of material. So we would blend these bricks up into the, like as the mesh kind of sits in, but it is a hard seam. In this particular case, it was fine because like the texture is the information and texture is so noisy that you really don't notice the seam. But yeah, there is a seam.
Okay, thank you.
Yeah, first, thanks. Great presentation, and your work is amazing. Really, it's really nice work. And I was wondering, what are you doing when you are doing simulation with Modo?
Mm-hmm.
The result baked is not something that is repeatable. You can't tile this texture. So do you have extra process to make it tile before baking?
No, so it gets tiled. See if I can show you the video. So just to understand, the question was, how do I make the simulation tile?
Yeah, exactly.
Yeah.
Because when it's simulated, it's not tileable at the end of the simulation.
So I'm not sure where it is.
You copy. It's the moment you copy some parts.
But here I'm just making a selection from one side,
And you draw.
and I delete it, and then just copy over the other side,
Okay.
and that makes it tile.
Okay.
So yeah, every time I do a layer, I make it tile.
Okay. And my last question is, if you have kind of a node like simulation node directly in Substance Designer, won't you be happy of this? Like
I would love that. Yes.
It's like it's a missing one because there's a lot of people that are doing
Yeah.
this. You're just only using Modo to do the basic shapes because it's
Yeah.
really hard to do this procedurally, like
Mhm.
those shapes. So okay, so let's say this to algorithmics.
Yeah. In reality, in practice, the process really isn't that bad. So it is quite cumbersome, but this was like 30 minutes work. So if you do need to go back and make adjustments, it is quite quick. So all in all, it's not a bad process to have to actually go through.
Okay, thanks a lot.
No problem.
Hey, thanks
Hi.
very much for the talk.
Thanks.
For the smaller, like 2 by 2 meter modules that you were planting around to plug holes and such, so after you have your simulation in Modo, you end up with a really porous mesh. I was wondering, what is your quickest way that you found to generate a good, clean, low poly that's going to work for that?
Yeah, so that process is quite challenging, I found. The low poly was decimated in ZBrush, but I did go through like making some smooth versions of the debris pile, with just like the smooth brush, and kind of I ended up sort of kit bashing together different decimated versions. But yeah, that process was quite challenging because the shapes aren't easy. But generally, they came from decimations.
Yeah. Thanks very much.
No worries.
Thanks. It's super awesome what you're showing. Do you have references or resources that you particularly think are great for learning the details of really kind of getting into understanding how to harness the power like the way that you are?
Well, for me, actually, the algorithmic YouTube tutorials is kind of where I started. And then I actually did a mentorship with Josh, and that was also super helpful. Right. But I don't know, there's so much free kind of like resource online.
Yeah, there are. I just wonder if there are any other ones that stood out, but those are two good references to begin with.
Say again, sorry?
Just other ones that stood out that you like kind of go back to regularly. Whatever else you can think of.
There isn't really anything that comes to my mind right now. But I guess, yeah, Josh and Daniel are really good resources. Chris Hodson as well, I found really, really helpful.
This is great work, like super beautiful.
Thanks.
Question on the simulation portion is, what drove you to use Modo over, I know you'd mentioned Houdini or any other simulation packages. Did Modo provide you something specific, and was it an intentional choice or something you just fell into?
Well, I use Modo just because that's what the studio uses. I was using 3ds Max primarily before, but I can definitely say I prefer the simulation tools in Modo. When you're actually doing the simulations, if you saw from the video, you basically get like a progress bar, and it all happens in the background, so you're never actually having it live, so it's a lot more stable. I suspect Houdini is great for this, and my reason for not using Houdini is simply because I don't know it yet. But that's something I would love to try out and learn.
Thank you.
No worries. Okay, I think that's it. So if you have any more questions, then feel free to contact me. Otherwise, thank you very much, and enjoy the rest of GDC.